To plot the means for this design, we use the command called margins plot. And this is actually a 2-series command here. Now, once you fit the ANOVA model, you can use the command margins, pints by sex. This will give us the means for each level, for attractiveness at each level of pints and sex. Right, so again, we can see the mean attractiveness for males who had 0 pints and so forth, all 6 means. And then if you simply use the command margins plot, it will plot that for you. And this will help us to visualize any significant main effects or interactions that we have. Right, so for this figure, we have on the x-axis number of pints. So people who had 0, 2, and 4 pints. And then represented by the blue line are males and the red line are females. And then finally, the y-axis is the average number or the average attractiveness rating. Now, when we look at this figure, we can see a pretty clear interaction here. One tip for assessing an interaction is if the lines cross each other. So in this case, we can see that males had a slightly higher attractiveness rating compared to females. Remember, this is non-significant, but it is slightly higher, and that's only for 0 and 2 pints. However, once males had 4 pints, the attractiveness ratings significantly decrease compared to that of females. So basically what we see here is that attractiveness ratings for females remains fairly stable across alcohol consumption, whereas for males, it significantly decreases. Another way to consider whether we have an interaction is by looking at the difference of differences. Now, that sounds a little bit complicated, but I'm going to reiterate this a lot for the rest of the semester. That essentially means when you're visualizing the plot, is the difference here different from the difference here? So is the difference in attractiveness ratings between men and women different at 0 pints compared to 2 pints compared to 4 pints? What we're seeing here is that the difference between 0 and 2 really doesn't look that different. However, at 4, it's definitely more extreme. So we can see that the difference between males and females at 4 pints is different than the difference between males and females at 2 and 0 pints. All right, so now that we've gone through the demonstration with these data, the last thing that I want to do with the remaining time is giving examples of other similar figures and how we can assess a main effect or an interaction. This is a skill that's going to be very useful to you guys, especially when it comes to quizzes and exams. Now, each figure here is completely fictionalized data, but using the example that we had before. And each figure here is just to demonstrate what it might look like if we have different types of main effects or different types of interactions. So let's take this one by one. Just like before, the y or the x-axis is represented by 0, 2, and 4 pints. And the y is attractiveness ratings. And in this case, orange represents female and blue represents male. Now, there are a couple of tricks when you're looking at a figure like this to assess whether you have main effects. For the example in the top left corner, we have a main effect of sex, and this is pretty clearly demonstrated here. We can see that consistently at 0, 2, and 4 pints, women are consistently rating attractiveness higher compared to men. So this would be an example of a main effect of sex only. There's no main effect of pints because the values don't change at all between 0, 2, and 4 pints. The best way to assess if there's a main effect of the variable that's represented on the x-axis is to actually draw a new line. So you'll want to draw a new line that's essentially giving the average between men and women. So you draw a dot here for 0 points, for 2 pints, and for 4 pints. And then draw a line connecting those 3 dots. If there's no slope to the line, that means there is no main effect of whatever variable is on the x-axis. Now, to consider if there's an interaction, really what you're looking for is that the lines are not parallel. In this example, in this top left corner, the lines are very much parallel. If the lines continued on, they would never cross, which means there's really no interaction here. So this just represents a main effect of sex. Next, in the top middle, we can see a main effect of alcohol consumption. Again, if we plot those dots, if we created a new dot between males and females, it would be right in the middle. And that new line does have a slope. Let me change the color, that's a little difficult to see. So here we can see that there is a slope to this line, which means we have a main effect of alcohol consumption. But in this case, there's really no difference between attractiveness ratings for males and females. So we don't have a main effect of gender or a main effect of sex. We also don't have an interaction. Now, the top right, we can see that the lines are definitely not parallel, which suggests an interaction. If the lines continued on in either direction, they would definitely cross. But this figure also represents a main effect of sex. When you have a figure that looks like this, there is a trick for identifying if there's a main effect of the variable that's represented by the lines here. And to do that, you really just want to draw a line right in the middle. So averaging across number of pints, this would be about the average value for women. And then same thing above. You want to draw a line kind of right in the middle, which would be the average for men regardless of number of pints. And if there's a difference between these two lines, which we can clearly see here, there would be a main effect of sex. Continuing on to the bottom left, this figure represents a main effect of sex, a main effect of alcohol consumption, and a significant interaction. Again, there's an interaction because the lines do cross, they're not perfectly parallel. And for this example, there is a main effect of sex. Remember, if we draw those lines, if we draw a line right in the middle, sort of averaging across pints, that's very different for men compared to women. Right, so this top one would be the average for males and the bottom is for females. So there's a very clear difference here. Now to assess if there's a main effect of number of pints, remember we want to actually draw 3 new dots. So we want to get the average attractiveness rating for 0 pints, which is pretty easy. For 2 pints would be right in the middle there, and for 4 pints, right in the middle there. And then again, you'll draw a line connecting these dots. If the line has a slope to it, then we have a main effect of pints, which that's what we see here. All right, and then the bottom middle, we can see we definitely have an interaction because the lines actually cross. And this is specifically called a disordinal interaction. In this example, at 0 pints, women are rating attractiveness much higher compared to men, and that effect actually flips. At 4 pints, we can see that men are rating attractiveness much higher compared to women. All right, so this would be considered a disordinal interaction, and in fact, we don't even have a main effect of sex or pints. So if you were to just look at the main effects of sex and pints, you might say that there's actually no effect of either. But in fact, we have a very strong effect, a very strong interaction. All right, and finally, if you have no interaction, you might see a plot that looks like this. where attractiveness ratings for men and women are exactly the same at 0, 2, and 4 pints. No main effects and no interaction. Now, this is an exercise that I recommend you practice. It's definitely good to understand how to visualize figures like these and assess if we have any sort of main effects or interactions. This is also something that I would expect to see on a quiz or an exam. All right, so remember for next week, we're going to be continuing on with the same example, and we're going to be assessing simple effects. So if you have any questions about our practical today, make sure to reach out to your instructor, and have a good week.